We want to find the exact value of cosine alpha minus beta, and then we've got some information about sine alpha and sine beta. So the first thing I'm going to do is I'm going to draw a triangle for alpha, and I'm going to do the same thing for beta. Looking at the information, sine alpha is 24/25 and alpha is in quadrant 2. So I'm going to make an angle in quadrant 2, and I'm going to label the sides so that the sine is 24/25. Sine is opposite, that's 24, over hypotenuse, that's 25. Now I can use the Pythagorean theorem to find the missing side, and it looks like that is 7, but I'm going to make it negative because x values are negative in quadrant 2. Now I'm going to do beta. Beta is in quadrant 4, so I'm going to make a triangle in quadrant 4, and I'm going to label it so that the cosine is 8/17. Cosine is adjacent, so that's 8 over hypotenuse, which is 17. And then I'm going to use the Pythagorean theorem to find the missing side, and that's going to be 15, but it's negative because y values are negative in quadrant 4. Now that I have those triangles drawn, I am going to find cosine of alpha minus beta, and I'm going to do that by using the difference formula for cosine, which is cosine of the first angle, cosine of the second angle. It's a minus here, so it's going to be a plus here, sine of the first angle, sine of the second angle. Now, all I need to do is pick off those angles by looking at the triangle, putting in each of the pieces. So I need cosine alpha, so go to the alpha triangle. Adjacent over hypotenuse is -7 over 25. Now I need cosine beta, so I go to the beta triangle, and adjacent is 8 over hypotenuse is 17. Now moving over, I need sine of alpha. Going to the alpha triangle, I do opposite, which is 24 over hypotenuse, which is 25, and then I need sine of beta. Going to the beta triangle, I've got opposite, which is -15 over hypotenuse, which is 17. The last thing I'm going to do is I'm going to do the multiplying and kind of combine that, so I can see that they will have a common denominator. These numerators are going to give me a -56. And I've got 24 times 15 is 360, going to be -360. So when I'm combining those, the numerator is going to be -360 minus 56. Looks like negative, so I'll just put the negative out in front of the fraction, 416. And then the denominator is 17 times 25, and that is 425. Now let's look at another example with sine. So similar type things. We're going to do the same type setup. We're going to draw a triangle for alpha, and we're going to draw a triangle for beta, and we're going to label it so that what we have given is true. Alpha's in quadrant 3, so make a triangle in quadrant 3 and label it so that the sine is -4/5. Sine is opposite, so the -4 goes opposite over hypotenuse, and the missing side then would be a 3, but I put a negative on it because we're in quadrant 3 where x values are also negative. Now I'm going to do beta. It says beta's in quadrant 4, so I draw a triangle in quadrant 4. And I need to label it so the cosine is 12/13. Cosine is adjacent over hypotenuse, and then I find the missing side, which is a 5. I put a negative on it because y values are negative there. All right, let's go ahead now and write out the difference formula for sine. We got sine of alpha minus beta. That's going to be sine of the first angle, cosine of the second angle, minus cosine of the first angle, sine of the second angle. Plugging in our various pieces by looking at the triangles, sine of alpha is opposite, -4 over hypotenuse. cosine of beta going to the beta triangle. We got adjacent 12 over hypotenuse. Now going to the next part, I need cosine alpha. Looking at the alpha triangle, adjacent is -3, hypotenuse is 5, and then I need sine beta from the beta triangle. Opposites -5 over hypotenuse is 13. So it looks like when I multiply those, I got a -48 for this first two and a 15 for the second two, but I got a minus between them, so it's going to be -48 minus 15, and we'll put that down below here. It's going to be -63, and the denominator, 5 times 13, is going to be 65.